Good morning, everybody. Welcome to our database series, week 5. Can you believe that? We already in our week 5, going through our database technology stuff. Pretty cool stuff, right? So hopefully we'll be able to cover, all the database. Maybe not, in depth, but at least we cover all the basic components of the database. And then if you're interested in further, you can actually elaborate, you can study more in depth. Okay, so before we started this week, week 5, let's go ahead and recap exactly what we did last week. Last week we ended with installing a sample database, a Sakila database, right? Did you get a chance to take a look at the sample database to see, how many tables are they and how each table in the database are structured? It's good for you to practice learning a database by looking at the sample database, because this will give you a glimpse of um, how the real world database looks like. Okay, maybe it's not like a real world database, but this is kind of like give you a glimpse of it a little closer, a little bit closer to the real table in the real world database look like. Okay, so let's see, and make sure that you actually practice, running your SQL select statement to query the database. Okay, right, and then we just want to show all the database available that we install in our database engine using the SQL command show database. So we know that Sakila is the one that we, right? And then we want to show, we go into Sakila database, right? We have so many database available. We go into Sakila database and then we want to show all the table, right? So we have, this is the list of all the tables, right? Now you have to practice your SQL, your select statement, your all of this stuff, right? Using the where clause, the order by clause, the having clause, and the group by clause. Try to do all of this stuff, okay? Like I have a sort of like a sample database of sort of like all the IP address in the world, right? And I try to select, take a look at some specific table and try to run the select statement, right? Right? You can run this one right here. You take a look at, oh, the IP address of this one belonging to which country, what location it is in the world, and then if they have any images available, right? You take a look at all this stuff. And then you take a look at all the IP address that is in the United States, right? You run your select query statement against the table nmap trace route, right? F5, so on and so forth. You have to practice, right? So you really, really have to really practice writing the SQL statement, and try to make use of, the where clause where you set the condition, right? And then group by, order by, is sort of like you try to rank them, sort, group by. When you want to rank, when you want to sort, you use the group by, order by, okay? So that is actually for last week. And I really encourage you to do a lot of practice in terms of writing SQL statement, select statement, and then try to run them to see exactly, the result that you got it from the data set, okay? Because database, without, that's how you learn database, just a lot of practice consistently on a regular basis, daily basis, weekly basis. Set out maybe three, at least like 3 days, probably like 1 hour and a half each day, a week that you can practice all this stuff. Okay? And today, so if you really, really pay attention to what we have been doing so far from week 1 to up to this point, week 5, we started out with learning how to read the database by focus by focusing on the read operation, which is like the second operation in the four operation of the database, the create, read, update, and delete, right? So we focus on the read operation of the CRUD, right? And then after that, we learn how to write. You know, we started out with learning how to read the database. After that, we learned how to write. We write just a little bit of SQL statement to create a small tables, you know, our table, a very small table, and then we insert some record into that tables, right? And then after that, we basically install the sample database so that it can give us the glimpse of how the real world database look like now. So now we want to actually, this week I want to focus on, I will be focusing on the database design because learning database isn't just querying, running the select statement, you know. Learning database is all about creating a database, you know, a database design. Why database design matters? Why? Because you know what? The design of the database is a foundation. It's accounted for 80% of all the database related activities, right? In order for you to search item, you need to store those items into the right tables. And in order for you to have which table to store, you have to have, sort of like a blueprint, a design of the database to be created first. So why the database design matter? Because it is the foundation, right? It's make up 80% of all this stuff, and then retrieving, updating those make up the remaining 20% of it. So why it is a very, very important for you to really understand. It's kind of like the database design, the ERD, the entity relationship diagram for the database, for the DBA database administrator is just like the blueprint design, a sketch for the architecture before they can actually store a furniture into which room in the house. You know, you go to living room, you place this furniture, bathroom, the master bedroom, the restroom, right? Before you can actually place furniture, you must have a house first. But before you actually build a house and divide it into a smaller room, you know, a living room, a master bedroom, a kitchens and all this stuff, the architecture, they usually do a blueprint for the, so that's what it is. The ERD for the database is like the blueprint for the architecture, okay? And then let's say that during the design phase, if you want to change, it's always easier for you to change during that designing a prototype than when you're already into when like the house already built and then you try to correct that. So it's a lot easier for you to correct it when it is still in the sample, in the very sample version of it. Okay. So that's why database design is really, really important. Let's say that you have 18 months, a year and a half to develop a software automated tools for a small business, for a small merchant, right? I would say that the first 6 months out of 18 months, we should use that for understanding the business information, the business requirement, the business rule, so that you be able to create the right table for that database, right? Okay, but now, before we created the database from scratch, we have to understand, the symbol, the notation of, like our entity relationship diagram. So let's take a look at our database project description. Okay, the one that we take a look at this one, right? Now this table are given for sort of like the bookstore database, right? But later, let's say that you have to create all of this table from scratch on your own. You have to understand the business rule and gather information so that you be able to create the right tables, for that database. Now we have the books, right? We have customer. Remember, last 2 weeks ago, we created one table, which is the customer tables, right? And now you have books, and you have order, and you have order details. Well, in the ER diagram, it will show you three things. It shows you the entity, right? Which is this one right here. Each of these are entity, Books in entity, customer is an entity, order is entity, order details are entities, right? The employees, I would assume that the employees might be the author of a book. Right here is the employee, okay? By looking at this one right here, and you know that, oh, the books and the customer, the ER diagram will consist of three main things: the entity, the attributes, which is the column, right? And the data type for each attributes, right? Customer, you actually have the customer ID, which is a primary key, name, address, email, right? And then the relationship between these tables, right? Like I said, the database is collection of a lot of tables, and we're gonna link this table, and this table are related in a logical way. We're gonna link, this table using a mechanism known as primary key and foreign key and composite key. Okay. So we have tables, we have attributes, we have columns, right? For those tables, we have data types. You declare the definition for each table, by declaring the name of the tables, the attributes for that tables, and the data types, right? And then after that, you're gonna link all these tables together using a mechanism known as primary key and foreign key. That's why over here, if it is a primary key, they just have this one right here. They listed the first attribute, right? Those are things. And then you take a look at the relationship line. You can tell, how is one entity relate to the other entity. Let's say that books and customers, I think there's some correction to be made here. So this is, what is shown at the database project description, but the relationship between books and customers, let's say that you have to understand the notation, the symbol. The notation symbol and the crow's foot notation is sort of like a legend for the map. So you have to understand the map notation, the legend for the map, okay? So this is, I would say, okay. Let's say that you have the sample for the relationship, to describe the relationship between the entities. The gross foot notation will have one, it's just a vertical line. 0 is like 0. 1 is a vertical line, and many is kind of like a grow foot notation. This is a grow foot notation here. That's just signify the many, okay? Let me try to see if I'll be able to explain this stuff a little better. Okay, so now, if you take a look at books and customers, there's a little correction to be made here. Books and customers, and you try to find out the relationship by asking this set of questions, okay? You're asking customers can order many books, right? The customer can order many books, right? Either at least one book or as many books as he wants to purchase, right? Otherwise, you must purchase one book to be considered customers, right? And the relationship between a books to a customers, right? A book, one book can be purchased by many customers, right? Or a book doesn't have to be purchased at all. It's sitting in the booked inventory, and it doesn't have to be purchased. A new book just got published and it's into the book inventory, so the book doesn't have to be purchased. So the minimum number of book can be purchased is 0, but the maximum number of book can be purchased by customer is many, right? So when you take a look at this two table, very simplify the scenario. Two tables, books and customers. Books is entity, books. The second entity is customer. The customer to books, you can buy many. So that's what you need to do, this one right here. Let me try to see if I'll be able to do this. Let's say this is your, right? You represent the entity using a rectangle. This is a customer here, right? And then this is a book, right? Sorry, guys, I don't have a pen. I'm using my finger to draw these things right here, you know. I'm saving money to purchase a pen. It's just kind of funny. This morning I light up for breakfast and someone from the shelter asked me if I have a nickels. I said, I don't have any money. But anyway, you know, I'm saving money. Someone told me that I need to sort of like get a bamboo pen to write on my tablets. Okay, so you have a customer and books, right? This is going to be a two-way relationship, right? First relationship is from customer to books, and the second relationship from book to customers. Okay, so now you have this line is a relationship line, right? Okay, so customer can buy a lot of books, but at least one book to be a customer, right? So that's going to be a vertical like here, right? And then the maximum number of books a customer can buy, they can buy as many as they want. So that's going to be a crowfoot notation here, right? And then you take a look at the second, another direction from book to customers. How many books, what is the minimal number of books can be purchased by customer? The books doesn't have to be purchased. It's sitting in the bookshelf, right? So it's a 0 right here, right? And then what is the maximum number of books can be purchased by customers? You know, the customer can purchase a lot of books. Book can be purchased by a lot of customers. So that's going to be a crowfoot notation, many. Okay? You know, that's going to be like that one. This is sort of like a relationship line between the customer and books. And you have to ask the set of questions. What is the minimal number of this instance? The instance is book. The instant for customer is a customer. Okay, it's the first customer is a first instant. Second customer is second instance. Instance, first book, second book. Okay. And I think, and now I feel like the relationship lie between the customer and order is correct. Okay, a customer can place many order with this, which is this crowfoot notation here, right? And then one order can only belong to a customer, right? It's like that transaction order, that specific order transaction is belong to only one customer. So that's why you see this vertical line here. So remember, vertical line is one, crowfoot notation, many, okay? And then ignore these things right here. Just pay attention to the first one right here. The order, remember that customers can place many order, right? Can place many order. But one order cannot belong to one customer. And this order detail, you need to have this order detail. Let's say that the customer can place many orders, and then within one single order, they can purchase, you know, more than one book. So how do you actually going to resolve this many relationship? Okay, then you have to create another intermediate table called order details. Why do we need order detail? Let's say that one customer purchase, you know, 4 books in one orders, right? So how do you store 4 books in one order, right? You know, you're gonna have the list of all these books, you know, separated by comma, book 1, comma, book 2, comma, book 3. So that's why you need to have this order details table. And for each book, it will be a record, a row for this order details, right? Let's say that this table right here, one record, it only recorded the order ID, the order transaction ID, and the customer, the buying this in the total amount. And then the order detail will tell you, okay, if you buy 4 books, then, you know, it's going to be the same it's going to be a 4 records, 4 rows in this table order detail with the same order ID, but a different ISBN, right? Which is like the ID for book, right? So you're actually going to have the order ID, the same order ID, but you have a different ISBN for different books. And this is what they call composite key. Composite key is a combination of 2 or more columns that uniquely identify a record, right? So that's how you resolve the many relationship of an order for one customers. Okay, and then you know what we discuss about these employees later. Employee basically just like book. One book can be written by many employees. One book can be written by many authors, and then one author can write many or publish many books, right? So this is a many-to-many relationship. And when you have many-to-many relationship, you can resolve that many-to-many relationship using intermediate tables, just like how we have customer and orders, okay? But right now, let's focus on the first four: book, customer, order, and details. A little correction being made between books and customers, okay? That's it. And remember, database design is very important. It's account for 80% of it. So when we talk about database design, we're talking about how do you create the correct table and the right number of attributes for that table. And that requires you to understand the business requirement. That's why I'm telling you, you know, that's part of the software product development cycle. You know, in order for them to develop tools, they have to understand the business requirement, business needs. You know, it's kind of like before you can automate any task automatically, you have to really observe to see how the tasks are done manually first before you can automate this task. So you have to really understand, you know, the first phase of any software or product development cycle. They have to spend time understanding the business requirement. You know, they come into the business asking exactly what do you want to capture, you know, what do you want to do on a daily basis, and what is your business rule, you know, in order for you to create out this one. But right now, for this, for all database assignment, all you need to do, you have to understand the symbol notation, right? The Crowfoot notation is whether it's a one-to-many relationship or one-to-one relationship or many-to-many relationship. Understand that, okay? And then the next part is for you to sort of like recreate it, the database yourself, okay? So now, let's try to create the next table. Last time we created the customer. Now let's try to create books, okay? So you have book, right? So you have, let's say that last time we created the table customer. This time we created book, okay? It's always a good practice for you to sort of like drop a table before you create that table. That way you're not gonna create a duplicate tables. Let's say you want book, right? Create book, right? And then you have ISBN, which is the primary key. ISBN, integer, not primary key, right? And then you have title, right? This is how you declare the definition for the table, the structure of your table. Author, right? Voucher, and then you have publisher, voucher, comma, right? Genre, you have oh, you know what? We already have books. Okay. Forget it. We're not gonna create. We already have books. Yep. You're gonna comment this whole thing out. Just when you comment it, it's I believe it's control. Okay. You commented out Control K, Control C. Okay, drop book. We probably have the code to create the book tables here. Sorry. Right. Right. Okay. So now take a look at it to see if we have if we can run this code source. Ah, we have to make sure that we can run. Right. Okay. Now show database. The name of our database we created for that file is summer 2025 yellow, right? And then we want to show the table so far. Okay, so we have book, we have customers already. We have, let's see if we have any record in our customers. Select from customers. Oh, no as. Okay, so we have two person, two record in our tables. And I'll take a look to see if we have any books, right? Select from book. Ah, we have, two books so far. Okay, now we want to insert more record into books, okay? More record into books. Let's say that you want to, let's say that we're gonna do this one right here. Mm-hmm. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, right? That's going to be our third book, right? We save it, we run it again. Okay, show tables. Then select book. Remember that we just added one more record in books, so we should have 3, right? See that? Okay. Now, now you can complete incident populate data into the book tables by doing that. Basically, just run this, follow this syntax right here. Whenever you're not so sure what is the syntax to insert, to add a record in SQL, always use the W3 School, okay? Because out of many online resources, I like this one the best so far. This one right here, right? SQL, this is where you find all the correct syntax for updating a record. Select a certain record using the where clause condition, group by, learn, all of this stuff. Okay. Okay. So let's try to insert another one. And you comment it out by, I think it's, comment it out. Remember that the dash dash is basically just comment it out. Okay, and then you just have to make sure you follow the right syntax for adding. There you go. Right. Okay, make sure. Okay, that's going to be all. Save that. Then run this code again. Okay, now you should have for record. Okay, that's for book. Okay, so that's how you created a tables, and that's how you populate data into that tables. Okay, but before you create tables, you have to create a database to hold the table. This is the code for you to create a database. Right? So this is the code for you to create a database. You drop the database, you create a database. I use the summer 2025 yellow. That's the name of our database, right? The name of our file is a fun summer yellow database, but this is the name of our database. So I created before you can insert it, a data into table must be created. Before the table must be created, you have to create a space, a database, okay? And then remember that last week we installed the Sakila database, right? We basically download a zip file. It has two files, a schema file and the data file, right? That's exactly what I need you to do for this week. You know, you basically gonna sort of like create this database, and then the schema is kind of like just like the structure of the tables in terms of attributes, and then you link them together using a mechanism called primary key and foreign key. Okay, a primary key of one table being referenced by another table is a foreign key in that table. Let me say that again. Let's say you have two tables, table 1 and table 2, right? In table 1, there's a column that references the primary key of the table 2. That column reference the primary key of the table 2 in table 1 is called a foreign key. So a primary key of the second table is being referenced in the first table is called the foreign key of the first table. Everybody get that? Okay. So remember that they use key in order to link all this table together. It's kind of like you need to sort of like get a key to get into the room, right? It's a similar concept. Okay. So now if you take a look at our database project description, you're going to see that you have this is the schema right here. They create a table. They declare the definition of each table and the structure of each table, right? And which one is a primary key, which one is foreign key, right? And then after that, this is the second part where you populate data into each table, right? So that's a data file. You can actually combine all this together in one file, the schema and the and data, okay? So that's going to be our homework for next week, for this week, okay? Do that, and then if since the database is a little more important, I'm going to cover a little bit more than just 1 week on the database design. It's a foundation. That's why it matters. It's 80% of it, okay? Try to follow the syntax to declare the definition of the table, right? This is how you declare. This is how you declare, right? The definition, the structure for the table, and this is how you insert data into it. Very simple, okay? All right, guys, so I hope you have a good time, and until next week, try to do our homework for this week. Create the schema and the data file for our database for this project right here. Okay, that's it. Until then, take care, and I'll see you next week. Okay.